verse. Let's look at solving equations that involve logarithms of different bases. So how are we going to solve equations that have logarithms? Well, to get rid of the logarithms, we'll use exponentials with the same base. So let's take a look. Let's start with the first problem, A. On the first problem, A, we have 2 log base 3 of x equals 4 over 5, or 4/5. First, before we do anything though, we need to get the log in the x by itself, so we need to get rid of the 2 that's out in front. We're going to do that by dividing both sides by 2. This will get rid of our 2 and will leave us with a log base 3 of x equals, well, how do we divide a fraction 4/5 by 2? Well, remember, dividing is the same thing as multiplying by a reciprocal if we're talking about fractions. It's keep, change, flip. So this would be the same as taking 4/5 and instead of dividing like we have, we would multiply by the reciprocal of the 2, which means you flip that upside down. Well, 2 is 2 over 1, so if you flip it upside down, it becomes 1/2. Then we can multiply straight across the top and straight across the bottom, which will give us 4/10, which is a normal fraction that can be reduced. That will reduce to 2/5. So now what we have is log base 3 of x equals 2/5. The question is, what do we do next? Well, next I need to get rid of that log base 3. How do I get rid of a log base 3? Is with an exponential with the same base. So I'm going to rewrite each side as a base 3 as an exponential. That means whatever's on your side will become the exponent. Well, what that does is that should get rid of our log base 3 and the base 3 with our exponential, leaving us with just the x on the left-hand side. And on the other side, we end up with 3 raised to the 2/5, or remember what's on the denominator is the type of root, so I can rewrite this as the 5th root of, well, what do we have here? We have 3 squared. Well, 3 squared is just 9. So I can rewrite this 3 to the 2/5 as the 5th root of 9 if I want. Those are 2 different ways to write the same answer. Let's come back to B. Let's go ahead and try C. For C, we have the natural log, or ln, of 2x equals 5. We've already got the log by itself. It's a log base e because it's a natural log, so all we need to do is get rid of it with the exponential that is its inverse. Well, the ln means we've got a base e, so we're going to use an exponential base e on both sides. Notice again that means whatever you're using the exponential base e becomes an exponent on both sides. However, the natural log and the e cancel out on the left-hand side, leaving you with whatever was inside, which is a 2x. And on the right-hand side, that leaves me with an e to the 5th power. Now I just need to get the x by itself, so I'll divide both sides by 2. So what that does is that gets me that x equals 1/2 e to the 5th power, or you can rewrite it as e to the 5th over 2. Either way, both answers mean the same thing. Continuing along, we've already done problems A and C, so let's take a look at B and D. So in problem B, we have 7 log, and again, it doesn't say what base. If it's an log log and we don't see a base, remember that it's a hidden base 10 of 2x equals 10. Well, the first thing I need to be able to do is get rid of that 7 that's out in front of my log. So I'm going to divide both sides by 7. That'll get me started at least. What that does is gets me a log of 2x equals 10 over 7. Then what? Well, now I need to get rid of that log. Well, again, it's a base 10, so I need to use an exponential base 10. That means both sides are going to have an exponential base 10, and whatever's on those sides will become exponents to that base 10. So what does that do? Well, on the left-hand side, the log base 10 and the 10 will cancel, leaving you with the 2x. So let's see, we've got a 2x. Equals, on the other side, we've got 10 to the 10 sevenths. So that's 10 to the 10 sevenths. Last thing we can do to get x by itself is divide both sides by a 2. And that gives me that x equals 10 to the 10 sevenths divided by 2. Now, I do know that most students, it's very tempting to want to divide the 2 that's on the bottom into the 10 that's on the top. You want to divide this 2 into the 10, but you can't. Why? Because order of operations says that you would have to do your exponents first. You have to be able to take care of the 10 to the 10 sevenths first. And we don't want to do that. So you can't divide the 2 into the 10. Also, they don't have the same base, so you don't even need to worry about doing anything with exponents. So your answer has to be left as is. It has to be left as 10 to the 10 sevenths divided by 2. There is nothing you can do with this other than maybe the only thing you could do is use the 7 on the bottom to rewrite that as a 7th root of 10 to the 10th. So that's about the only thing you could do, but it doesn't really help you. It doesn't look any nicer, so we're just going to leave it just like this. Moving along, let's take a look at D. In D, we've got the natural log of 1 minus x equals 1/2. And what we're going to do is the natural log is already by itself, so the question is, how do we get rid of it? Well, we're going to get rid of it with an exponential base e. Again, we'll do that to both sides, so that means whatever's on your left and whatever's on your right-hand side of your equation, when we do the exponential base e, will become your exponents. Now, this is nice because the ln and the e are both base e. They will cancel out just like we were hoping, leaving us with what was inside, the 1 minus x. And the other part gives us e to the 1/2. Now, there is something special that's going on here. Because of the 1/2 and the 2 being on the bottom of that exponential here, on the part of your exponent, they probably have you rewrite that as a root. The question is, if you've got a 2 on the bottom, what kind of root? Well, if it's a 2, it's a square root. Of what do you have there? Technically, you've got an e. Let's see, you've got, an e to the first power, but that's just e. So I've got a square root of e on the right-hand side of my equation. Let's continue along with that. 1 minus x equals the square root of e. So the next thing you naturally want to do is get rid of that 1 that's off on the left-hand side. Well, it's a positive 1, so we're going to get rid of it by subtracting 1 on both sides. So what that will do is that will get rid of my 1 with a negative 1 and leave us with, be careful, that's still a negative x on the left-hand side, equals the square root of e minus 1. The last thing that we do is divide everything on both sides by a negative 1. And that gives me that x equals, well, remember that dividing by a negative will switch the signs of everything. So I have to divide everything on top by a negative 1. Well, dividing the square root of e by a negative 1 will turn that into negative square root of e. Dividing the negative 1 by another negative 1 will turn that into a positive 1. And that's my final answer. X equals the negative square root of e plus 1, because dividing by a negative switches all my signs.